So next thing we need to look at is solving inequalities with the modulus function, and these can be a bit trickier. What I want to do is just try and get the understanding there first. So let's just think about what this means. So we're saying that the size of x is less than 2. Let's go proper old school and think of a number line. So that means it's got to be somewhere in this bracket. If the size of x, the modulus of x, is less than 2, it's got to be somewhere here. All right, it's got to be somewhere along that line. Anything outside of it, the modulus of it is not going to be less than 2. For this one, so here I'm saying that the modulus of x is greater than or equal to 3. So again, let's think number line. So that means 0, 3, or negative 3. So if the size of x, the modulus of x, is greater than 3, I know it's got to be somewhere up here, or it can be equal to it, so that's filled in. So it can be anything up here, or it's down here. It's one or the other. Now, these are onto two important statements that we're going to need to use when solving inequalities with the modulus function. And they are: an inequality of the form the modulus of some function is less than a, so that's that first one on there, we can write that as it's somewhere between a and minus a. And you can probably guess for the second one, if it's in the form that it's greater than a, it can be written as f of x is either less than negative a or it is greater than a. Obviously, if you've got the lines underneath, then you just carry those through to those inequalities as well. So, for example, if that was greater than or equal to a, then these would be greater than or equal to here, and this would be greater than or equal to here. So how do we use this to solve them? Well, so it means that I know that I could rewrite that. I know if that is less than 7, I know that, well, it's in that first form, so I know 2x plus 1 is less than 7 and it's greater than minus 7. So that's the first step. Solve it like I normally would with an inequality of this type. So I can just take 1 away from everything. Negative 8 is 2x and 6, and divide it all through by 2. As always, just be careful if you're solving these. I don't normally see them with negatives, but if you end up dividing or multiplying by a negative, you're going to have to flip those inequality symbols around. So negative 4, x is between negative 4 and 3. So again, let's think about what the graph looks like. Well, the modulus of 2x plus 1 is something like that, and I want to know when that's less than 7. So graphically, what's going on? If that is 7, I've worked out we want to know these points here, because that is the region where this is less than 7. And I've worked out that point there is minus 4 and this is 3. So that's what's going on graphically. Again, you should always sketch the graphs with these modulus functions. I'm going to keep saying that. So here we go. So this one looks slightly trickier, but much like we were doing when we were solving the equations, let's just rearrange that. So if I rearrange it, so we've got that's less than 2 by taking away 1 from both sides, and that is greater than 1. So I'm solving that. So let's think about the graph this time first. So that is the modulus of x minus 2, and I want to know when that's less than 1. Oh, I've not done this poorly, so we want to know it's less than 1. That's 1. I want to know when it's greater than 1, sorry. So I'm talking about this region here, and I'm talking about this region here. But I've got to find those points, and that is when, using the rearrangement or the rewriting this another way, that is when x minus 2 is less than negative 1, or when x minus 2 is greater than 1. So that means x is less than 1 or x is greater than 3. And so that these points here that I basically worked out are 1 and 3. And I would probably just pick a few examples and pop them into that first inequality just to check they work. And again, drawing these in your calculator will help you no end. One point to make here is you cannot use the same technique at this point So for ones that look like this with just the modulus symbol on one side, you cannot use the technique of squaring both sides. This is going to give you some false results. So please don't do that for this. It's okay with equations. That's not so much of an issue, but it won't work for these ones. So don't with the inequalities, and you've got the modulus symbol on one side. Do not square both sides to try and solve the inequality, because sometimes the right hand side might be negative, in which case sometimes the inequality symbol flips and it just gets very messy. So use this technique for solving inequalities like this. However, what if there is a modulus sign on both sides? Well, because in this case both sides are positive, because we're talking the modulus, that's what the modulus does. It changes things from negative to positive if it's negative. This I can square both sides. So square the left-hand side, square the right-hand side, and then you've got an quadratic inequality to solve. So expand it and start solving it like you would do for a normal quadratic inequality. So now I've got this, I've got a quadratic inequality to solve. So you think about it like an equation. Now I know this factorizes because I did this earlier, but let's use the quadratic formula for this one. Again, if you use your calculator to solve this, that's okay, but just show the quadratic formula with everything substituted in correctly, just to show where those are coming from, so it doesn't look like to the examiner you've just shoved it in your you've just put it in your calculator to solve. So put it into the quadratic formula. X equals minus b plus or minus the whole square root of b squared, so notice I'm putting everything in, minus 4a what c, oh no, space, all over 2a. That's all you need to do, and so you put it on your calculator and you get out minus 2/5 or 4. So that is kind of the minimum that you'd be able to put in an exam to guarantee the marks for that. So what I'm saying here is that's kind of my side. So if the best way, again, draw the graphs or sketch them at least. So I'm saying that this is a quadratic. We know what that looks like. It's a parabola. It hits at negative 2/5 and 4. So it looks something like this. And I want to know when it's less than 0. So I want this part here. So I know that x is between negative 2/5 or 4. And that is how you would solve them if you have got the modulus sign on both sides. So please pause the video and have a go at these questions, and then I will go through the answers in a second. So the first one's quite easy. Don't forget you can't do the squaring until h at the earliest. So there are your answers for A and B. It's just a case of putting into practice the fact we can rearrange it into those forms. There are your answers to C. So it's greater than, so we're going to have either this one or it's this one. We cannot combine it. Please do not, when you get something like this, try and combine it into x is greater than 6, and for like that makes no sense if you think about it. You're saying it's greater than 6 and it's less than negative 6. That doesn't work. This is why we have to write it when it's like this as two inequalities, either that top one or that second one. There is D. So we're saying it's the modulus of that is less than 6, so I know that it's either less than 6 and, well, it's less than 6 and it's greater than negative 6, which is why I can combine it onto this one. Now, for something like this, you might actually just prefer straight away, because you're used to seeing it in the other direction, as just changing it to this. There's no problem with doing that. And it works out to be that x is greater than or equal to 0 and less than or equal to 2. Again, pick a value or two in there and just pop it in there to make sure it does work. Bit of rearranging to begin with, and then we can solve it. And there you go with that one. Right, so the solution for this one, I followed going through the same method. So I said that x was greater than this, and then less than the negative version of this, and it's going to be one or the other. Now obviously I've got some really weird solutions again. I've got the x is minus less than -4, or x is less than -2. So hopefully we didn't just put those down as answers, because that doesn't make any sense if it's one or the other. If it is less than -4, well then it's automatically less than -2. This is why, again, it's so important to sketch it to see what's going on. It's not just to like an extra add-on to like use up more time. It is really important for things like this. You get the graphs and they look like this, and I can tell that only one of these solutions is valid, and it's going to be this one. So the only solution you would put there for this is this one. This does not work, and this is why drawing the graphs are so important. So I end up with this quadratic, and this factorizes a little bit easier than the rest of the ones we've done. 3x x plus 6. So again, if I think about drawing this graph here, where again it's parabola, so if I'm solving this inequality, I know it's weird going from something like this modulus to something like solving a quadratic inequality which is curved and natural looking, but it's just obviously the method we're going through, we end up solving this quadratic inequality. So it's going to hit at 0, so it's going to hit at 0 and -6. So it looks something like this, and I want this area here because I want that to be less than 0. So x is greater than or equal to -6, and less than or equal to 0.